Our last conic section is the hyperbola. The locus definition for the hyperbola is a little bit more complicated. I think if you look at the diagram here, the animation, you can kind of get an idea about what's going on. It's the location of all the points whose difference of the distance from 2 points is constant. So if I have a point along my parabola and along my hyperbola, and I measure the distance from that point to both foci, the difference between those lengths is going to be constant. So here are all the characteristics for the standard form for the hyperbola. I want to point out just a couple things. There's a lot of similarities in the way things look with the ellipses. In fact, we're going to use a lot of the same techniques for graphing the hyperbolas as we did with the ellipse. The equations have a minus sign instead of a plus sign, and if you have a standard form equation, that's the easiest way to tell whether you have an ellipse or a hyperbola. And since it's a minus sign, it matters which order these are in. With the ellipse, it really didn't matter. I kind of like to put A first, but it wasn't really necessary. But here we've got x subtracting y, or x squared subtracting y squared. And here we've got y squared subtracting x squared. And so whether the hyperbola opens to the left and to the right, or whether it opens up and down, depends on which of x and y is subtracting the other one. In this case, it doesn't matter about the relative sizes of a and b. One can be bigger than the other, doesn't matter. We're going to have a graph box again. We're going to have this C thing. Notice the equation's a little bit different. And vertices and foci. Okay, so as before, we'll go ahead and do a completing the square. And so I'm going to just copy everything down here. Move the 113 over to this side, 113. And then I'm going to go ahead and group my x's and my y's together. I'm going to put a plus sign in here, even though I've got a negative y squared, and I think that's going to make things maybe a little bit easier. And I need my negative in front of the 9 here, plus 54y. All right, so now we're going to go ahead and factor out the 4 in this case. And I'm going to factor out the negative 9, so I'm going to have a minus here, minus 9 y squared, and then factoring out a negative 9 from 54 gives me negative 4y. Okay, so be sure you understand what we're doing here. When we take the negative 9 out, if I were to redistribute this and go backward, I would have negative 9y plus, this should be 6, plus 54y, negative times negative, equals 113. Okay, so let's go ahead and complete the squares. Negative 2 over 2 is negative 1. Negative 1 squared is positive 1. Negative 6 over 2 is negative 3. Negative 3 squared is 9. Okay, so I'm going to write 4 times x squared minus 2x plus 1 minus 9 times y squared minus 6y plus 9 equals 113. Now the numbers I have to add to both sides, I've already added here 4, and here I've added negative 81 because of this minus sign right here. Okay, so this thing really counts. So this is going to give me plus 4 and minus 81 on this side. Alright, so this is going to now become 4 times x minus 1 squared minus 9 times x minus 3 squared equals 36. And so once again, I'm going to divide everything by 36 so that we get the 1 on the right side. And so let's go ahead and just do a couple steps at once here like we did with the ellipse. 4 divided by 36 is going to give me a 9 on the bottom. And I'm going to subtract 9 over 36 is going to give me 4 on the bottom. This is y as well. divided by 4, and then I've got 1 on this side. And so this is my standard form for the hyperbola. So I have x squared subtracting y squared, and this tells me that this is going to be the left-right flavor. All right, so let's pull the characteristics from here. We're going to have h equals 1, k equals 3, a equals 3. Remember, this is a squared, and b equals 4. So we have also this c number here, and the difference here is that this is 9 plus 4, not 9 minus 4 like with the ellipse. And so when we do that, we get square root of 13. Otherwise, very similar to the ellipse. Center point is going to be at hk, 1 comma 3. And so we're going to have vertices are going to end up at 4 comma 3 and at -2 comma 3, and the foci are going to end up at 1 plus square root of 13 comma 3 and 1 minus square root of 13 comma 3, and the approximation for those are let's see, 4.6 comma 3 and -2.6 comma 3. Okay, so these would be all of the characteristics that we pull from the standard form here. Let's go over to the graph. We're going to plot the center at 1 comma 3, 1 comma 3. We're going to do the same thing as we did with the ellipses in terms of a graph box. So we're going to go to the right and left by 3 units, by a units. Okay, so the width of our graph box is plus or minus a. So 1, 2, 3, 1, 2, 3, and then the height is plus or minus b, which is 2, 1, 2, 1, 2. So I'm going to sketch a box around here. Okay, now if this were an ellipse, we would draw the ellipse inside here, but as it turns out, this is a hyperbola, and we're going to go actually in a different direction. So the hyperbola is going to have 2 branches, 2 curves that are going to be facing away from each other, okay, opening away from each other, and their vertices, their vertices are going to be right on these points. So in order to get an idea about how narrow or how wide to make them, we're going to use asymptotes, and the asymptotes turn out to be just the diagonals of the box. So I'm going to just draw lines through the corners. Okay, and this one I can tweak a little bit. I guess make this a little bit closer to the corners. That's good enough there. And so now I need to put in the focal points and the foci, and so we had the first one at -2.6 comma 3, so that's -1, 2.6 is out here. So you notice that it's outside of the box. For the ellipse, it was inside the box. So it's going to, be inside of the curve in either case. In the ellipse, the curve went this way, focus was here. Now we're facing out the other way. The other one was at 1, 2, 3, 4.6, so somewhere right about here, comma 3. And so that would be our left-right hyperbola. And I can be all proud of myself by comparing that with the computer-generated version. So pretty good rendition, I'd say.